let's get started with the review then. Double check one more thing. Okay. It doesn't appear that we have 3.1, but I thought it did. Let's look at it. Limits. These last two, don't do them. We're not going to cover the epsilon delta definition. And this guy, it's in your homework, but I'm not going to test you on this guy. We haven't covered it, so there will be one or two of those on your exam. So if you see them, skip them. If you do them, and maybe I'll give you extra credit, but they are not for grade. Okay. Don't waste your time on those problems. Is what I'm saying. Do everything else. Okay.
That's the review.
This is a review, yeah. But the exam should have one or two or both of these similar questions. It won't be the exact same, but you'll have a question about epsilon delta right here. See how it says the Greek letters right here? It's the last question, last two.
I'm sorry. Do you have any more students coming to these? If so, that's fine. I'm tired. I have to be back here at
Yeah, yeah.
7 in the morning.
Well, they can
You
always.
might want to have a student just check the door every night because I don't think they'll be able to get in.
Yeah, no worries. They
Okay.
should message me.
Okay.
If something happens, don't worry about it.
All right. Thank you. Y'all have a good night.
I'll take care of it. Go get some sleep. Okay. Yeah, this is the review. You have a different question, or is it out of order? It might just be randomized.
Well, mine has a box at the bottom, yours doesn't.
Yeah, so that's the big paragraphs. Yeah, so last two, skip them. So let's get to work. All right, let's share the screen. I'll record this for you guys. So the first one, mine are numbered weird. I'm pretty sure yours says number 1, right? On your end.
So it's from 2.2. Yeah, mine says what's the access code? I didn't actually read the
I have no idea what the code is. Let me see.
Radio.
They're ready? Yeah, ready. You can ignore this. I haven't updated it.
That's one review chapter 1. Got it.
Type in ready. It should open. Right. So number 1. Use your graph to evaluate the limit. If the limit does not exist, type DNE. So for these, there's not much to say, but so I'll try to write down like how to phrase it. So for number 1. They give us the limit. Let me write this question down. F as x approaches -1. Okay, so you look at the graph. -1 is right there. So as we get closer and closer from the left side and the right side, the function is going to what? See, that's 1 up there. So this is in quarters, quarter, 2 quarters, a half. The function is going to a half in both directions, right? So that will be your limit. So on the paper, you would just say, because you're gonna have a graph, right? As x approaches, as x approaches -1, the function approaches 1/2 from the left and right. Therefore, the limit of f is equal to 1/2. You can also say in symbols, since the limit of f as x approaches -1 from the left side is equal to the limit of f of x. X approaches -1 from the positive side. Since they are equal, then equal to 1/2, sorry. Is it the same? Going to 1/2, both directions. Then you can just simply say the answer. So I wrote right here. So I'm cool with however you want to write it. Want to just put it in English and just say, yeah, well, it's doing this, going to this value. The y values are approaching some number from the left and right as x goes to the number they're talking about. You can say it that way if you want. Just plain English, I don't care. Mathematically, this is the shortest way to write it. Okay. Any questions on how to answer these?
That little rectangle box that it has there, it'll give us space to be able to just type all that out.
No, you're gonna write all this down. I don't care about the answer choices. You're gonna scan your work. Don't forget. I'm gonna be grading the work.
Oh, okay, so good point.
Yeah, whatever. I think it'll check you correct for 0.5 or 1/2, but I'm gonna be grading the work. So later I'm gonna go back in there and see if you deserve the points.
Leave it blank as long as you got the explanation.
Yeah, like I don't care what you pick. If you pick it wrong, but your work's good, then it's right.
Oh, okay, so really big, you don't care what it is.
Do it blank or put answers, whatever.
So the little dot on the other line that was there on the positive side is just kind of there to throw you off.
No, not necessarily. Basically, the function is defined over here. So this would be an example of a function that's not continuous at -1, but the limit exists. It's not continuous because the function is not equal to the limit value. If the function would have given you 1/2, then it would be continuous because the limit's equal to 1/2. So they're creating a problem on purpose that's not continuous. But they didn't ask about it, right? No, I guess not. Anyway, does that make sense? Any questions on this? All right, so that's first one. Number 2. Let me share the screen again. So okay, use a graph to evaluate the limit. So the limit from the left as we approach 0. What is the limit on the left side? Negative side. What's the limit on the right side? Do you see it?
Oh. -2,
There's -2, and the other one's going to be
2.
2, right? They're not the same. So how do we phrase this, right? So since the limit of f of x as x approaches 0 from the right, let's say negative first, is equal to -2, you said, right? And the limit of f as x approaches 0 from the right is equal to +2, then the limit does not exist. It must be equal. For the limit to exist. Like we said up here, right? We said the left and right were the same, therefore the actual one exists. Here, the left and right are different, therefore the limit does not exist. They must be equal for the limit to exist. Any questions on 2? Oops. That makes sense? You see why it doesn't exist?
Yes. They approve 0 from both sides, they're not the same.
They're different, you just say it doesn't exist. So just explain that, explain why. That's all you gotta do. Why it does not exist. And if it does, you can say this as well.
What's that little word, is that and in between on the top?
For number
Is that
2 or
between
number
the
1?
Two limits that you wrote, the first line that you wrote on number 2. What's that little-
Yeah, since this and this. Yes. I wrote it weird.
just wrote it on.
Yeah.
It's like that other point she was talking about. Just wrote it.
Any other questions on number 2? You guys cool? All right. Share the screen so it shows up on the recording. Number 3, for the function f, determine the limit. Separator enters with commas, blah, blah, blah. Limit does not exist, put D and E, etc. Okay, so here it says, find the limit as of f as x approaches -1 from the left side. Okay, so here's -1, right? So as we get closer and closer to -1, we're getting closer and closer to this value, right? From the left side. So as we're going this way, we're getting closer to this. But from the right side, as we get closer and closer to -1, this is the special number we care about. It's this one. We get closer and closer to -1, we end up going to -7. So these numbers are going to 2 different places, right? Visually. Limits will be different. So you would just say, since the limit of f as x approaches, what is it, -1, right? Is not equal to the limit of f of x as x approaches -1 from the right, then the limit does not exist. Of course, you'd have to write the limit somewhere, so I'll write it down here. So since the limit, left side and right side are not equal, then the limit does not exist. So that's pretty much all you got to say. But the question did say to give the limits. So the left side was, what was it again? -2, right? Yeah. The limit from the right, I think -7. there any questions of where these numbers are coming from? Does that make sense?
It would be different the way we're writing it as number two.
It's the same. I wrote it a little different.
Now you have the not equals. Same as up there, right? Instead of the.
You could write it this way or that way. It's the same argument. It is written a little different. It's true.
Is it based off of where are the numbers you're getting based off of where the dots are?
It's the Y value that we're approaching.
Oh,
So whatever Y value we're getting close to, because the dot could be a hole, it doesn't matter. But what would the Y value be if it was filled? And if it is filled, then yeah, sure, it's where the dot is. So the hole is at -2, and that's where -1's at, so sure. Dots over here, -7. Any other questions on 3? Doesn't seem too bad, right, so far? I hope. You guys cool on number 3? I'm gonna turn the page in a second. Then. Number 4. These are graph to evaluate the limit. Okay, here's my graph. As the limit of x approaches 0 from the left side, what's happening to the y values? Yeah, it shoots off, right? So what is the limit? Yeah, you would just say infinity. Number 4, I would just say as the limit approaches 0, the function grows to infinity, or goes to infinity, either way.
but hold on, since it's the 0 plus, wouldn't it be coming from the other side? So it would be going down?
Oh, yeah, you're right. Sorry. Yeah. Negative infinity. Thanks.
It's like extra points.
Right. Get 1 point.
Hey, I need all that shit, okay?
Yes. Make sure you correct me as early as possible, because if I do a problem with like 3 pages and that the mistake was on sentence 2, I'm gonna be real pissed off, man. Happened to me last week. I'm teaching differential equations, and one question can be like 2 or 3 pages.
What?
They suck, man.
What?
Some of the math problems, they can take a few pages, and I forgot like one stupid thing at the beginning. I was like, all right, you know what? Just forget it. Just start a new question. Just forget it. The idea is there, though, guys. But it's wrong.
I had to do differential equations in the fall.
Oh, bro.
Yeah,
Oh, that's right. You're engineering, right?
yeah.
Cool. Yeah, I'm doing it right now, so maybe I'll see you. You need to get Cal 2
I'm
done
doing
first.
that over the summer. So
Oh, that's gonna be horrible.
it will, but
But I'm sure you
Did
can.
you count 2 in the summer?
Maybe.
Okay.
Summer is always random. I never know what I'm gonna teach.
this first.
Yeah, we'll get there. But yeah, today I had a lecture and it was like an hour and a half and I could only finish 2 questions. A lot of time.
So sad.
Yeah, they're be intense. And nobody knew what the hell I was talking about. Like I asked them many times. Did I lose you somewhere? Like, well, I know this problem was an hour long, but do you remember where you got lost?
So, wait, no, go back like 2 hours ago.
All right. Let me start over. I'll do it, but I don't know. I'm gonna stay late. All right, we're on number 5, right? Yeah. Well, anyway, it's a fun class. Find all the points where the function is discontinuous. Determine whether the discontinuity is removable. Explain your answer. This one,
Just put it fits all 3 conditions.
yeah, pretty much. Only issue is the condition that says the functional value is equal to the limit has a hole in it, right? As the limit was, it's the same thing about limits.
It doesn't tell us which one. Actually, yeah. it doesn't matter.
Movable.
Technically, it wouldn't it be discontinuous at 4?
Yeah, it is just continuous. I'm trying to remember why it's removable. Usually, I said last time, it's removable if a factor cancels. But here we don't have a function to look at or to cancel anything. So the question becomes, why is this one removable?
Got me.
Sounds like another one to skip.
Yeah. Sounds like
Extra point.
it sounds like you're not putting on this.
No, I think it's because it's not jumping to a different location. If you have a discontinuity that has a gap, that is for sure not removable. This one could be, but I'm not going to take points off if you're not sure. This one is a little unclear. So you see something like this, tell me where it's discontinuous. That I do expect. But if you miss the removable part, don't worry about it. But that's why it's removable, because there is no gap in the function that it's connected. Yeah.
Would that be right in saying that it's discontinuous at the whole?
Right. Because then you would say,
it like at x equals 4, it's discontinuous.
and then you would say why?
So the whole makes it removable.
Well, those are 2 different parts. So you want the discontinuous is because of those 3 rules, remember? So the function is not defined there, therefore not continuous. But it is removable. So I just want you to just explain why it's discontinuous, and that'll be good. So you would say on paper,
Well, why is it?
because there's no gap. Here, let me pull up
Sorry,
the.
sir.
No, you're good. You're good. Just what I'm saying is, it is removable because the graph is not technically disconnected. So if it was completely like one of those weird piecewise type, you know what I'm talking about?
It's always something.
Earlier we had something like this.
3.
Yeah, we have another one going over here. This would be non-removable. It's tight. That one is technically removable.
it is hard to see without the equation. So you have to focus on the visual. I tell you that see a gap, non-removable. I prefer given an equation, but
This one doesn't have one. I don't remember why. That's what I'm telling you, don't worry about it. Just explain to me why it is discontinuous. That I do expect to be answered correctly.
There's no other choice, right? It's only removable and non-removable.
Yeah, makes sense.
So I would just say, what's it?
Yeah, makes it non-removable.
So all I want to see is this function is not continuous at x equals 4 because the function is undefined at 4, even though the limit exists at 4. So it's not continuous at 4 because the function is undefined at that location. So remember that one of the requirements was if the limit must exist. The function must be defined there, and they must be equal to each other. Those are the 3 things. So it's not defined, and so that means it can't be equal. So that fails 2 right there. So quote one of them or both of those 3 rules. Because it fails 2. This undefined part should be sufficient. You could just say a function is undefined at x equals 4, therefore it is not continuous there. That would be enough. Okay, does that make sense? Don't worry about removable. You guys cool on 4 and 5? All right. What's the limit of this guy? What is the limit for question 6? What do you do when they say find the limit? What's the first thing you should do?
Substitute.
Yeah, just plug it in and see if you can. Yeah, so substitute to see what happens. Are you able to?
Yeah, supposed to work it out.
Yeah, I'm asking you, what's the limit? Can you tell by looking at it?
Square root of 5. So technically the limit doesn't exist.
Let's see, 4 plus 4 plus 1 is 3. Yeah, it's 3. The limit is 3. So you are able to plug it in. You plug in 2 for every x, you get 2 squared plus 2 times 2 plus 1. So that's 4 plus 4 plus 1, which is 9. Square root of 9 is since you're able to plug it in without having issues, the limit exists.
This is why I use calculator.
That's fine. Do it however you want. Let's do it on paper because I don't expect you to do weird stuff in your head. Not why we're here. Find the limit. Of the square root x squared plus 2x plus 1. So the first thing you should always try on these problems is plug it in and see if you get an error or division by 0 or something strange. If you don't, then cool, you're done. That's a nice question, right? Super easy. Nothing to do. Any questions on 6? Not too bad. Plug it in. 2 squared plus 2 times 2, whatever. No problems. If we would have got a negative inside, then that would be a problem. Then we may need to graph it and see if there's something it approaches, and if there's nothing or they're different, whatever, then you say does not exist. Next guy. This one looks like it may cause a problem, right? You plug in -4. -4 plus 4 is 0. So right away you should see, okay, this is causing division by 0. So back to the top and see if you can cancel, which would be an example of a removable discontinuity. Didn't ask though, so. Find the limit. So as the limit, x approaches -4, x plus 4. Okay, so what does that top part factor into? Yeah, 5 and 4, that's right. So notice that they cancel, right? So that is a removable discontinuity, in case you were curious. So at this point, you are allowed to plug it in. You get +1. -4 plus 5, 1, right?
I think what made it tricky last time was getting the concept that even though we're scratching out the x plus 4, it's the x plus 5 that's considered.
No. The part that would be removable is the number x, or the point at x equal to -4. So like if we graph this guy, just look at the graph so you can see it better. So f of x is this weird garbage. So notice that's a straight line. Pretty weird. Do you see why it's a straight line? So these cancel out, right? We just showed that on the paper. But do you see that this equation is the same as the red one, right? So that's all that's left. So in the if it was technically the red one you can plug in whatever you want. I'm sorry, the green one you can plug in whatever you want. The red one, even though they are technically the same, because it came from that cancellation, it has a hole there. So it's not continuous there because of it. So what we can't really see is this value here. So in the red one, there's a hole right there. So limit exists. There's a hole. So not continuous. But because it cancels and becomes the green one, it is considered removable. So it's almost as you filled the hole, I guess.
Yeah, -4, right?
Yeah, at -4. Does that make sense? That's the idea behind it, but as far as the question, you just cancel the term and you plug in the number. That's all I got. Any questions on that?
How do we do like figure out which one the removable term is gonna be in this test?
Maybe.
So the removable term is the one that cancels out, right?
Yeah, it's basically if it cancels out and it was causing division by 0 to begin with, yes.
Okay, there's the, I was looking at the other one from the actual chapter, and it was the opposite.
Yeah, well, let's look at it right here. X plus 4 canceled, right?
Yeah.
But the problem was the -4, not the +4. Because when you plug in -4, you get 0 down here. So this factor cancels, which allows you to fill or remove the x equal to -4. Does that make sense?
Sort of. I'll figure it out.
So yeah, they are backwards, but there's a reason.
So if it's gonna cause the 0 in the denominator,
Yes.
it's the term that cancels out, that's the removable one.
Yeah, the value that caused the division by 0 that canceled out
That's your,
But if it's not causing the division, if it doesn't cause a division by zero, it's the other, the one that doesn't get canceled out, that's removable.
it has to cancel to be removable. So if it doesn't cancel, then it's just not defined there. It would just be discontinuous. Like, let's say you change the number, right, to something else, then these canceled. I'm like, well, it didn't really matter because you could have plugged it in anyway, without problems. Find the limits. Any other questions on 7? Okay. All right, let's move on then. Find the limit. The limit as x goes to 0, 5 sine x minus 1. So what's the first thing you do?
Navigate it to sine x over sine x. Right?
No, we don't have to. First thing we do is plug in 0 and see if it's okay, right?
Oh, yeah.
Is it okay? What's the sign of 0? You guys took pre-cal, right? At some point.
The sine of 2. Cosine.
X cosine, sine y. So what is the y value at 0 degrees?
0.
It's going to be 0. So that is 0 minus 1. That's it. So in this one, it was literally easier than most of them. Just plug in the number. So make sure you do that first. Don't overthink it. First, check. Can I plug it in? Is it that easy? And if it's not, then okay, then I'll fall back to other stuff. Okay. Don't miss the softball questions. Any questions on 8? Okay. Number, whatever that is, a 9, I guess. You guys cool if I turn the page? Or not yet? Find the limit. This one I would recommend you graph it. Otherwise, it'll be more complicated.
What cues give you that absolute value?
The fact that I can't just plug it in or I can't do any factoring, any algebra stuff. There's not much to do. And that's what like makes me think it's a weird looking graph. So I should just graph and see what's going on. But they also didn't tell me to use algebra, right? Like the last few. See how they've been saying find the limit algebraically over and over again. This is the first one where they don't tell me that. So that means I can do what I want. I'm gonna graph it. So okay. So what's happening at -4? As I approach from it's at the plus side, right? So they come from the right. What is the functional value? Yeah, it's always 1 no matter what, right? Until we pass that point. So the limit would be equal to 1. So just to say in English, right? As x approaches, -4 from the right the function goes to 1. That's it. Any questions on 9? Find the limit algebraically. So I'm sure this looks familiar from your homework, right? What do we got to do? Yeah. You got to do conjugate. So multiply by the conjugate. Top and bottom. Conjugate means the same thing, but just change the sign to opposite. So we have a minus, now we have an opposite. I gotta do it to top and bottom to keep balance. Sorry, spaced out. So multiply these out. There's going to be a difference of squares. Remember, I said it's always going to be this way. At bottom, I'm just gonna leave it like this. Yes, see why it's squared, do you remember?
I always remember that that negative was on the outside of the parentheses.
It's always on the outside.
That's the one that I forget. I'll put it on the inside.
Yeah, you should just remind yourself it should be a difference of squares. It cannot become a plus. But I hear you. Careful. So this will be squared, cancels the root, we get 1 plus x minus a 1. 1 squared is 1, the negative is outside. So at this point, we end up with, let's go down here. With just an x on top, right? These cancel. Now you can plug in the limit, right? So the whole point is to create an opportunity to plug in your 0 in this case. Any questions about any of the steps? You guys cool with conjugates? You cool with the different squares? Cool with the algebra? So
Place of the money, when you're writing all this down, you have the 1 plus x. And usually this comes first, so that you're writing it down. One thing at a time. It'll look better. If that makes you right.
you're talking about the,
No, at the very bottom.
Uh-huh.
Yeah, the whole thing, it's got 1 plus x. Right from the PC equation, the x is first.
oh, I see what you're saying. Yeah, I mean, you can write it the other way anytime you
Yeah,
want,
and
but I see what you're saying. It's a little weird.
throws it off.
It's kind of like when you get something like this. Like this one throws people off a lot. Right, you have to distribute. But we're used to seeing the thing at the front, but it's the same. This is technically right. But this is very weird for some people. Confused. Like when people write x2 instead of 2x, it's like, what the hell? I mean, not wrong, but you're a weirdo.
It's like when you're writing like.
I mean, that's the thing, though. It's not technically wrong punctuation or anything. It's just strange. It's a good
explanation. It's more like a style, an understood way of writing things. It's not technically a mathematical rule. Reference. Anyway. You guys cool on 10 then?
I finally got something on the homework.
One half, right?
Yeah. Should be. I effed it up. Alright, 11. Find the limit. How would you guys approach this one?
I just look at it. Oh, wait, no. Zero.
You should try until you notice, right? You can't. And since you noticed it, what else do we do?
Graph it.
Yeah, I would just graph it, not worry about it. So you should get this. It's a graph here. The question said, as we approach -2. So what's happening in -2? They haven't asked them to, but they're going to 2 different places, right? So what would you say?
Negative infinity.
It's not a one-sided limit, so it's the regular limit. If they're not the same, what does that mean for the limit?
Oh, it does not exist.
Yeah, so that's the answer. You just put D and E and explain that. So
Because
number,
one goes to negative and one goes to positive infinity.
yeah. So 11. Since the limit from the left 1/x+2. Just gonna call it F because it looks weird. It's not equal to the limit from the right, then the limit does not exist. Here it didn't ask for the actual limits, right? Well, one-sided. So this would be enough. It just said, what's the limit? None exists because they're not the same. It's okay. But you could have said as well, if you wanted to. From the left, we're going to negative infinity. From the right, we're going to infinity. Okay. Is 11 clear?
Yeah, put D and E, refer to number 3.
As long as 3 is good, sure. That when you read the graduate level math books, the examples, they'll start the proof
And they're just saying, we'll leave this to the reader to finish. I'm just like, I'm trying to find out how you do this. I'm like, oh, yeah, the reader will figure it out. I'm like, I'm the reader, and I don't know what's going on.
Oh,
They love doing that stuff. Like, this proof will be left to the reader. I was telling one of my other classes, like, the further you go, and well, in any rule, in any subject, the more alone you become because no one can really help you or tutor you or answer your questions. Google gets more and more sparse, and confusing. So you're just on your own for a while. Like my professor, and he was a logician, was pro in logic. So all his papers and research were in logic. And there's only one dude in Israel that could read his papers and tell him that makes sense. There's just one guy in the world. It's like, yeah, that looks good, man. That's just it. No one else can read them. I just thought it was hilarious. Like, they've gone really far, incredibly alone.
I'm okay with not knowing that level of math. Like, yeah, I'm okay with not knowing that.
Yeah, it's whatever. Can't know everything, right? But I mean, it goes for any real topic. If you go in a very specific route, go really far, you'll be by yourself.
So it's that guy.
Only logic can.
So that's why.
Yeah, I guess so. That was another thing a professor told me. So don't use your logic on your girlfriend. Never ends well. Like, you don't want to keep winning arguments based on logic. It just pisses people off. I gotta learn to chill out with that stuff. But anyway, what do you guys think about this guy? What would you do? Same thing, right? Looks like it's exactly the same as the last one. So I hope, yeah, same exact. C number 11. I'll leave that to the reader. That's it. The last, oh no, this one's fine. Last two, don't do those. Yeah, it's not exist.
even though this time it's giving specifically the less.
Good catch. So what is it? From the right.
No, don't scroll out. I can't see now.
Doesn't want you to notice this.
Hey, let's make it more obvious. There's the -7, right?
So this case, it would be
From-
infinity, right?
From the right, yeah. Infinity. Thanks for catching it. Got 2 points today. Yeah. Yeah, there's not much to say here. I would just say let's put this in words. As x goes to -7, the function goes to infinity on the right. I would say from the right. So
So as x goes to -7, the function goes to infinity from the right. There's nothing to do, really,
So from the right or off the right?
from.
Okay.
And again, I would accept both, I mean, it's whatever. Just explain it, and you'll be good. 13. One second. Find the limits. So the limit, this is the one you were talking about, right?
Yes.
We have to use that rule that they listed in the question. That's right there. So as long as the u and the u down here are exactly the same, the limit goes to 1. As long as the argument of sign is the same as the thing on the bottom. So on our question, it's missing a 5, right? If they had a 5x down here, they would be the same and we would be done. So you have to introduce the 5.
We would do 5 over 5.
Yeah. Let's do it. So now we can apply the formula to this, but to be more proper, you should pull out the 5 on top, outside the limit. So this goes to 1. That'll be 5 times 1. That's it. Yeah. Oh, sorry. Any questions on 1 through 13? So don't worry about the last 2. Don't forget. If they show up and you do them, I'll give you extra credit.
That's, you know how to do it first.
No. You're on your own. And we're not covering that topic. Anyway, you guys are good on the first 13 questions? Is it okay?
And those are all things that are gonna be on the test. then.
Does it feel doable? we'll stop here then. You guys have questions, you're welcome to stay for a bit. Otherwise, I will see you